Good day, everybody, and welcome to our Mathematics of Investment class. This afternoon, we are going to learn about Lesson 8. It's about perpetuities. We can start by asking, what is a perpetuity? A perpetuity is a type of annuity. It means it has regular payments whose payments continue forever. So in perpetuity, there's no end. The payments are given T and it goes infinitely. And what are some of its examples? Examples, scholarships or a perpetual financial support fund. For example, when a money is given to a school for the endowment fund, we say it's for the scholarship fund, the school invests it in a perpetual financial support fund. And what happens? Based from that fund, it will keep on releasing money gradually, for example, every year or every month, and it never stops. You might ask, what happens to the original fund? The original fund does not increase, and it does not decrease as well. What only happens is that if in the general annuity, the interest or the perpetual fund is the one that is given every now and then. Now, there are different types of perpetuities. The first is a simple perpetuity. It happens when a payment interval is equal to the conversion period. For example, the perpetual fund is given every month, and the interest is also increasing every month. That is a simple perpetuity. If the payment interval and the conversion period are different, we call it general perpetuity. Example, the release is every month, but the conversion period is annual. So they are not the same. We call it a general perpetuity. The other is perpetuity due. It's a perpetuity where it is given at the beginning of each payment interval and it continues forever. If the payment or if the amount is given at the end of the month, we call it ordinary perpetuity. And the last is deferred perpetuities. These are similar to deferred annuities, wherein there is delay in the first payment. Now let us start with an ordinary simple perpetuity. And here's the formula that we're going to use for the ordinary simple perpetuity. If it's checked, A stands for the amount of annuity or the amount of perpetuity. R is the regular payment, and I is a periodic interest rate. Let's start with the first problem. A commercial bank is considering the establishment in perpetuity of a visiting professorial chair in business administration at the university. The cost would be $100,000 per month. First question. If money can earn 12% compounded monthly in perpetuity, what endowment is required to fund the position? Let's check first if it is a simple perpetuity. So to check if it is, remember that it's compounded monthly and it's also given every month. They are the same, so we call it an ordinary simple perpetuity. Let's identify the given. R, this is the one given per month, is 100,000. That's the regular payment. Then our J is 12% compounded monthly. Therefore, our M is 12. Let's solve for our I. Our I is J over M. That's 0.12 divided by 12. So our I is 0.01. Now we're looking for the money that we can earn. It means that we're looking for the amount of perpetuity. So we have A sub P equals R over I. Our regular payment is 100,000. while our periodic interest rate is 0.01. Thus, the endowment fund required is 10 million. Any questions? Feel free to message me in Messenger. The next one. What monthly compounded nominal rate would an endowment of 20 million have to fully fund the position? This time, we're looking for I. That's the nominal rate, the compounded nominal rate. So remember, I is taken from J over M. Now, we are looking for J, our nominal rate. But before that, let's solve first for I. Based on the formula, I is R over A sub P. Our R is 100,000, while the amount of perpetuity here as given is 20 million. Let's use our calculator. That's going to be 100,000 divided by 20 million. Here, check. It is 0.005. So our interest rate our periodic interest rate is 0.005, or that is 0.5%. To find for the nominal rate, here we're looking for J, right? So I equals J over M. Cross multiply. So J is equal to M times I. Our M, it's per month. So that's 12 times I, 0.5%. That means our nominal rate is at 6%, compounded monthly. If you have questions, feel free to message me in Telegram. Or in Messenger, I should say. Let's go to the next one. For perpetuities due, here's the formula. It's still the same. A of perpetuity due times I, that's our periodic interest rate, over 1 plus I. Again, when is it a perpetuity due? When the payment is given at the start of the payment interval. Let's have the first problem. A rural bank's preferred shares pay a dividend of 60 per share every beginning of 3 months in perpetuity. The next quarter dividend is not to be paid. First question, at what purchase price will the shares provide an investor with a rate of return of 12% compounded quarterly? Now, let us check with this problem. What is our R? What is it, 60? If we read again, the dividend, that it means that's the regular release, is 60. So that is our R, 60 pesos. Every beginning of 3 months. At the beginning, so it is a perpetuity due. Every 3 months is a payment interval, and the compounding is quarterly. They are the same, so it is a simple perpetuity. At what purchase price will the shares provide an investor with a rate of return of 12% compounded quarterly? Now let's solve. Our R is 60. Our J, that's the nominal rate, is 12%. Our M is 4. It's compounded quarterly. Therefore, our I is 0.12 over 4. That is 0.03. We're looking for the price. And the price is the same as the amount of perpetuity due. It's equal to R over I times 1 plus I. Let's solve. Our R is 60. Our I is 0.03. 1 plus 0.03. Let's use our calculator. That will be 60 over 0.03 times 1 plus 0.03. There. The answer is 2,060. So the purchase price is at 2,060. Next question. What will be the nominal rate of return if the investor is able to purchase the shares for 3,060? We're still looking for the J, but again, before we solve for the J, let's solve for the I. So I is equal to R over A minus R. Our R is 60. Our A is 3,060 minus 60. Let's use our calculator now. That's going to be 60 over 360 minus 60. There. The I, or the periodic interest rate, is at 0.02, or that is, to decimal places, 2%. But if we solve the J, the nominal rate, remember, J is equal to M times I. Our M is 4, that's quarterly, times I, so we have 8%. Our nominal interest rate is at 8% compounded quarterly. Any questions? Message me in Messenger. Next, let's go to the next example. The next example is for deferred perpetuities. It's the same as the deferred annuity. Check with a D. The D is asking us how many compounding intervals are deferred or not paid. Let's start. Problem number 3. Find the quarterly payments of a perpetuity whose present value is at 1,300,000 if money is worth 12.3% compounded quarterly. The first payment begins after 5 years. So if we check, the 1.3 million here is our amount, while 12.3%, that is our J, 0.123, compounded quarterly, or M, is 4. So let's compute for the I. That's going to be J over M. So our I is at 0.041. It begins after 5 years. Therefore, the first payment begins after 5 years. So how many deferred payments are there? That's 4 times a year times 5 years minus 1. Why? Because the payment is done after 5 years. So only 19 payments are not given. Let's now solve. We are looking for the quarterly payments. We're looking for R. So R is equal to A times I times 1 plus I to the power of negative D. Our A is 1.3 million. Our I is at 0.041 times 1 plus I to the power of negative 19. Let's solve using our calculator. We have 1.3 million times I times 1 plus I raised to the power of negative 19. There. The answer is 24,840.67. Let's write it. The quarterly payment will be 24,840.67. This is the regular payment for the perpetuity. Let's go to the last example. The last example is on computing general perpetuities. So these will be the formulas. Remember that a general perpetuity happens when the payment interval is different from the conversion period. Now, once we solve for general perpetuities, remember the C. C stands for the number of conversions per year over the number of payments per year. After solving C, we need to solve for F. That's quantity 1 plus I to the power of C minus 1. Let's start. What amount must be placed today in a perpetual fund earning 8% compounded semi-annually if monthly payments of $63,200 are to start? Now, the compounding is semi-annually, the payment is monthly. They are not the same. Therefore, it is a general perpetuity. But it will start today. Therefore, it is a general perpetuity due. It means it's at the start. Let's solve. The 8% here is your J. The semi-annually, your M is 2. And the 63,200 is your R. So let's now start solving. Remember, our K is 12 because that's for the monthly payments. Our I is J over M. That's 8% divided by 2. So 0.04. Sorry. And our C is M over K. Means 2 over 12. That's 1/6. After solving for C, we need to solve for F. And remember, F is 1 plus I to the power of C minus 1. So our I is 0.04 to the power of C. It's 1/6 minus 1. Let's use our calculator. 1, plus 0.04 to the power of 1/6 minus 1. There. Copy all. So our F is 0.00655819694. 97. In the book, it ends here. Just have 7. Okay. Now, excuse me for a while. The first one, let's solve for the annuity, the amount of perpetuity, but it's a due, right? Because it's given at the start. It's equal to R over F times 1 plus F. So we have R over F there. Times 1 plus F. Just copy all. Then let's use our calculator. There. The answer is $9,000,000 699,994.99. In the next problem, it's asking 1 month from today. So it means that the payment is given at the end. It's the same as the general ordinary perpetuity. Therefore, since we have that, our formula will only be A is equal to R over F. If you have our calculators, this one, you just delete the multiply 1 plus F. The answer will be 9,636,794.99. If you have questions, feel free to message me in Messenger. For now, this ends our lesson for perpetuities. Have a great day, everyone.